Alright, welcome back. This is our third video on section 7.6 of AP Calculus, finding general solutions using separation of variables. In the first two videos we introduced the concept of separation, did a bunch of examples, and we saved this example for its own video, since this is one just for folks who have BC Calculus, because this is a problem that is going to require us to use a technique that we learned in BC in order to integrate this all the way to the end. And that is namely partial fractions we're going to have to use on this one. So without further ado, I'm going to clear myself some space because I need plenty of space for this problem. Clear myself some space, and we're going to go ahead and look at part H. There we go. All right. So first things first, I'm going to go ahead and separate this problem. And in order to do that, I'm going to multiply both sides by dt, and I'm going to divide both sides by p squared plus 3p. So that gets us to the integral of, well, separate first. So we'll separate. We've got dp over p squared plus 3p equals t squared dt. So we're going to integrate both of those. And the right-hand side of this is simple enough. You know, this is going to be 1/3 t cubed plus a constant. So the left-hand side is the side that's going to present the challenge to us here. And the first thing we've got to do is we've got to go ahead and figure out what this is going to be with regards to our partial fractions. So let's see, dp dt, pardon me. We're going to rewrite dp, come on pen, where are you? All right. dp dt, my gosh, first my pen's not working and then my brain stops working. And now the eraser doesn't seem to want to work. Sorry everybody, I'm having some technical difficulties. Alright, so we want to split dp over p squared plus 3p into partial fractions. And of course the factorization of p squared plus 3p is p times the quantity p plus 3. So this is going to be equal to a over p plus b over p plus 3. And so a times p plus 3 plus b times p has to be equal to 1. Okay, and setting up my partial fractions, that means that a plus b is equal to 0, and 3a is equal to 1. So a is 1/3, and b is negative 1/3. And so I can split this into, I'm just going to factor the 1/3 out a while. I can split all of this into 1/3 times the integral of 1 over p minus 1 over p plus 3 dp. So there's my partial fraction decomposition. Of course, since the b value was -1, that's why I changed this to a subtraction, and I factored out the 1/3 so that I didn't have to worry about constants inside of here. And now I can go ahead and integrate the left-hand side. So I'm going to have 1/3 times the quantity natural log of the absolute value of p minus natural log of the absolute value of p plus 3. That's going to be equal to our right-hand side. I'm going to go ahead and multiply both sides by 3. So that gives us natural log of the absolute value of p minus natural log of the absolute value of p plus 3 is equal to t cubed plus c. So by the way, we're done with the separation. We're done with the integration. And here's where the algebra to solve for p really gets to be the difficult part of this problem. So we're trying to solve for p. Okay. On the left-hand side, since I have the natural log of one quantity minus the natural log of another quantity, I can combine that into a single natural log. That's going to be equal to the natural log of the quantity p over p plus 3. Now to get rid of the natural log, I'm going to raise each side to the natural log, or to the e to that power. Pardon me, I keep stumbling over my words here. E to that power. So I'm going to get p over p plus 3 is equal to c e to the t cubed. And these, of course, are different c's. We've been through this a couple of times through this separation process. And now let's see, I need to solve for p. So let's flip the, get rid of the absolute value, absorb that into the constant. So we've got p over p plus 3 is equal to c e to the t cubed. And now what I need to do in order to solve for p, I can't do p divided by p plus 3, but it's pretty simple for me to do the reciprocal of that. P plus 3 divided by p, I can divide the p into both terms, which is going to give me an inroad to simplify this algebraically. Now when I flip this, the c e to the t to the third becomes 1 over some constant times e to the t cubed. I'm actually going to rewrite that as a different constant, c e to the, and I'm going to change the exponent to a negative exponent, so that's up in my numerator. Alright, now on the left-hand side, I'm going to divide both sides by p. That gives me 1 plus 3 over p is equal to c e to the negative t cubed. I can subtract 1 from both sides. And then I'm going to reciprocate again in order to solve for p. So I flip the left-hand side, and I flip the right-hand side, and when I flip the right-hand side, I just put everything there under 1. And now I'm going to divide both sides by 3. Or pardon me, multiply both sides by 3. And boom, there is our integral for dp dt equals quantity p squared plus 3p times t squared. 3 over c e to the negative t cubed minus 1. Alright, we are now done with finding general solutions using separation of variables. We're going to come back in the next section and go ahead and talk about finding particular solutions when we have an initial condition. So we're going to use separation of variables and an initial condition in order to find one particular solution that meets both of those characteristics. Alright, we'll see you then. Go ahead and have a great rest of your day, and talk to you next time. Bye-bye.